Hi everyone, I am Carolina Toledano Galicia. I am a student at the Instituto Tecnológico Nacional de México, Campus Cuautla. I'm currently studying the 8th semester of the Computer System Engineering degree. In this video, I will tell about Grafana. Grafana is a powerful and flexible tool for visualizing and analyzing data, facilitating tracing and making informed decisions in business and development environments. Grafana is cross-platform with no dependence and can also be deployed with Docker. It is written in Go language and has a complete HTTP API. Grafana is based on visualization, which represents data in a way that the client knows what is happening. Consult, visualize, create alerts, understand your data no matter where it's stored. There are the famous dashboard that anyone can use, among other things. Before we continue with the next, an important point is the challenge of observability. Observability is crucial to understanding and maintaining model systems, but face several challenges related to complexity, data volume, diversity of data source, cost, scalability, data contextualization, problem detection, and organizational culture. Addressing this challenge requires a comprehensive approach that combines technology, process, and organizational culture. Before starting the demo, let's see what this demo will cover. For the demo, two architectures will we use a local one with Grafana and Prometheus. To start the project on our machine, we need to have Docker installed. Since, with the help of it, as it is a local server, it will help us execute the project. And OpenTelemetry is an open source observability standard that provides a common collection of tools, APIs, and SDKs to help collect observability signals. The OpenTelemetry community created a demo application with this that we are going to use that acts as showcase of the features and capabilities of the technology. Grafana and Prometheus in this part will help use analysis trace and with a set of predefined dashboards that query the data in prompt scale using SQL. Since we know the theoretical part, let's see the product demo. The demo app is a cloud-native e-commerce app made up of multiple microservices, in this case offering Telescope products, because it includes examples of 10 programming languages and OpenTelemetry supports with the ADK. The app is a good reference for developers on how to use OpenTelemetry. You can also use it to test different OpenTelemetry features and evaluate how they appear in the backends. Plus, you can use this a framework for future customization. Well, let's try it. On the homepage, we have the following products that they offer use. Let's make a purchase choose a product. See that we can change the quantity of products to be purchased and also how it is added to the cart. We can continue with the purchase if we can to purchase more. On the payment screen it already shows of the quantity of products and also the cost you order, and again you can continue with the purchase. As we see, this is the visual interactive part with the user. Now, what the client is looking for is this demo leverages the OpenTelemetry collector to generate metrics from distributed traces and export them as Prometheus metrics. Here, I'm going to use Prometheus Grafana, but this metric could also be sent to various observability tools, ensuring compatibility and flexibility in monitoring and analysis. Now, we're going to the local Grafana. We're heading to the dashboard part. In the first dashboard, it shows us various types of metrics and statistics related to the service of the page shown previously. Is the demos panel. We can see the latency for the adversary service. This is telling just long it takes for the system to respond when asks are requests. The error rate for ad service. A high error rate is worrying as it may indicate functionality problems. In service request free, we can see that high application rate indicates high demand, which is positive. We can also the application logs, in which we observe the requested entries and records of adversary service. This will help us solve problems in the system. Um, the application metrics, which includes the CPU time use, response time, and memory usage. These metrics are in real time. In this case, we are in the 5 minutes, but this can be changed to a longer time. Let's analyze this panel. The latency for ad service. We click on Explore, as we'll see it in Prometheus, that allows to show the code's monitoring and metrics. To see this data in more detail, we divide the panel with Split. Now we select Jagger, which will help us visualize individual traces. In search, uh, in service niche, we select from the web. The operation do is HTTP GET, and we run the query. It shows us a table in which we see the HTTP GET request trace for the period of time we want, in this case, in the last 5 minutes. Now, if we will click on any on the trace ID, we see the information in even more detail. This can help us solve errors, improve performance, and more. We have a second dashboard in which we can see that the information is separated into different sections that we can filter. Practically here we see receivers, processors, explorers, collectors, and data flows. In this part, I'm going to focus in looking at the file request sent by the OpenTelemetry Explorer. As a start, we see the panels generated for this demo. We can click on Edit and see each of them. Let's use the first panel to see the problem we have. We edit the panel with Select Prometheus, as a data source, and two queries appear. We are going to enter two queries in which we can understand and analyze each one. We are going to enter it directly from code. In this case, I have them in a notepad. For more quick, we just copy it and paste. and means we have the following sum. This prompt QL query calculates the sum of failure requests sent by the OpenTelemetry Collector Explorer in the last minute. The OTCL Explorer send file request metric tracks the number of requests that the OpenTelemetry Collector Explorer file intercepts. The rate function calculates the rate of increase per second of the metric if the time range specific in square brackets 1 minute in this case. The sum function the sums are the rates calculated by the rate function not over the specific time range, giving us the total number of final requests sent in the last minute. The query is filtered in the job, which is set to hotel collector to specify the specific instance of the monitored OpenTelemetry collector. In general, this query helps track the status and performance of the OpenTelemetry Collector Explorer, alerting administrators of developers when there is a significant increase of the numbers of file requests. The next query they perform is the following. This prompt QL query monitors the failure rate of outgoing requests from the auto collector job. Let's analyze the different parts of the query. Auto Explorer send file requests. This metric measures the number of file requests sent from the Auto Collector Explorer. Jobs and Auto Collector. This is a tag selector that filters the metric to only include data from the Auto Collector job. Rate. This calculates the rate per second of file requests during the last minute. Sum. This calculates the sum of the rate per second of file requests 0.8. This multiplies the above sum by to calculate the 80% threshold limit. And sale is round the final result to the nearest integer. Therefore, this query returns the maximum value of 80% of the future rate per second in the last minute. If the number of failed requests exceeds this threshold, it can be used to active an alert or perform some other action. This data seen right now is in real time. There on dashboard, there are the entry and exit process. It is easier to visualize. Each panel is configured in case something except the colors are what detonate if there are problems. For example, in memory, total, sendbook, and other. In the fourth dashboard, but not less important, show the performance and latency metrics, error rates, both payment and adversing service, the interface requests, and many more. Without further ado, exploring everything offered in this Grafana demo is a great tool for use to explore and learn about the configurations. Create our own dashboard and understand the analysis of our data.